Hi all. See, this is a problem appeared in the JEE Main 2019 and it says that, right, we are having two lines, okay, that equiline equation is given, okay, already, right? So this is one line, this is the second line, okay? Line means a straight line and this says that they are perpendicular, okay? And we have to find the right options for this particular job, okay? So that's the problem. Now, this can be treated as a vector problem, vector algebra, or obviously we learn that vector and the 3D geometry are very similar to each other, so we can solve the same problem in a 3D concept. So this problem is easy to solve using the 3D one, okay? So let's go ahead. So first we consider the line 1, okay? So here we consider the equation of the line 1. So that line says that x is equal to ay plus b, and it says z is equal to cy plus d. So see that from the first part, you can easily calculate y is equal to x minus b divided by a, and from the second equation we'll find y is equal to z minus d divided by c. So therefore, if I write down both the equation combinedly, we'll find x by b minus b divided by a is equal to y minus 0 divided by 1 is equal to z minus d divided by c. So what happens? So this is a straight line passing through the point B0D and having DRS. DRS means that direction ratio. Let us call it as the vector eta. That's equal to A I plus J plus CK. That's it. Now see that I wrote it here as eta cap, okay? But see that for direction ratio, right, we cannot say that it's eta cap. It should be eta, okay, vector, because it's not a unit vector. Yes, technically that's the general notation we use, okay? So that's why it should be eta cap. And in exam on everywhere, right, you have to write down that, don't write it as direction cosine, okay? Because direction cosine states means that it is a unit vector, right? Now, we don't know before testing, we don't know that, right, it's a unit vector or not. So every vector, whatever in this form, right, in that direction, it represents the straight line. That will be definitely direction ratio, right? So we can write, if it is a unit vector, still it's a direction ratio, right? So that's why it's safe to write direction ratios, okay? That's it. So that's it. Now let's go ahead and consider the second equation. For the second equation, let's go ahead and write down the equation. So it's give you that x is equal to a dash z plus b dash and y is equal to c dash z plus d dash. So if I write down that equation now, we'll find z is equal to x minus b dash divided by a dash. And from the second equation, we'll find z is equal to y minus d dash divided by c dash. So therefore, combining all, we can write x minus b dash divided by a dash, that's equal to y minus d dash divided by c dash is equal to z minus 0 divided by 1. So again, we'll say that this is a straight line pass through the point B dash, D dash and 0 and having DRS let us write down as zeta. Okay, let's don't write down as zeta. This is actually difficult to write. I again write it as a vector eta 2. It's equal to the vector a dash I plus c dash j plus 1k. That's it. So that's the problem. Now says that if they are perpendicular, as they are perpendicular, obviously the directions ratios, right, they are perpendicular. What is the direction ratios actually represent? Represent a vector along the line or parallel to the line, right? So therefore, if the lines are parallel, there the vectors is also perpendicular, perpendicular, right? So therefore, we can easily find that eta1 and eta2 are 0 dot product. So as both lines are perpendicular, so eta1 dot eta2 is equal to 0. Now as the dot product is equal to 0, we'll find that a dash plus this is obviously c dash, I missed that, okay? So c dash into j, so plus c dash plus 1 into c, so c is equal to 0. So that's it. So therefore, you can see that by this problem, obviously option A is the correct choice. So that's the equation. So it's a very straightforward equation. You can first convert to the coordinate geometry equation of the straight line, and then we find the DRS. You can go ahead with the vector equation of a straight line, but that problem actually generally takes a little bit longer time, because finding the DRS in coordinate geometry concept for this particular problem, it sounds easy, right? So it feels easy. That's why go ahead in the coordinate geometry concept, find the DRS and take the dot product. Okay, that's it. Hope you understood the problem and the easiest technique to solve this problem. Thank you.